Solving simultaneous equations. I've identified that these are simultaneous equations as I have two sets of equations that need to be solved with two unknowns in each. I need to work out what x is and I need to work out what y is. We're going to solve by a process of elimination. I can eliminate in these equations the y variable because the y variables both have the same coefficients. They both have a 1. I can eliminate them by subtracting one equation from the other. 3x take away 2x leaves me with x. Y minus y becomes 0, so I've eliminated it, and 7 take away 6 is 1. So x equals 1. I'm then going to put my value of x equals 1 back into one of my equations. I'm going to choose to put it back into this one. So when x equals 1, 3 times 1 plus y equals 7. 3 plus y equals 7. So y must be 4. Check that this works. If x is 1 and y is 4, it gives me 7. I just tested it here. If x is 1 here and y is 4, it also gives me 6. So x equals 1, y equals 4. I've solved for the two variables and it works for both equations. Let's try looking at a different one. So for this equation here, we have 2x plus y equals 21 and x minus y equals 6. For this, you should notice that now our signs are different. We have a plus and a minus here. So in order to eliminate, instead of subtracting the two equations, we now need to add them. 2x plus x gives me 3x. Y minus y gives me 0, so I've eliminated it. Remembering a plus and a minus makes a minus. And 21 plus 6 gives me 27. If 3x is 27, x must be 9. And just like before, we're going to substitute our value for x back into one of the equations. I'm going to pick this one to substitute my value of x back into. So when x equals 9, 9 minus y equals 6, which means y must be 3. And check that it works. Okay, so 2 times 9 plus 3, does it give you 21? Yes, it does. So I know that I've correctly solved my simultaneous equations for x and for y. To solve these equations, we're going to do exactly what we did before, but hopefully you've noticed that in this example, we do not have coefficients that are the same. The coefficients for the x values here are 3 and 2, and for y we have 4 and 1. But that's not a problem. All we need to do is make them the same. So I'm going to multiply my bottom equation by 4, therefore making the variables have the same coefficients. So I'm going to rewrite my equations. 3x plus 4y equals 20, and 8x plus 4y equals 40. Now my coefficients in front of y are the same. I'm going to subtract them just like we did before. Three take away 8 will give me minus 5. 4 take away 4, I've eliminated. And 20 take away 40 will give me minus 20. Minus 5x equals minus 20, which means x must equal 4. If x equals 4, I should be able to put this back into my equation to work out what the value of y is. So when x is 4, 3 times 4 plus 4y equals 20. 12 plus 4y equals 20. 4y equals 8, y equals 2. Okay, let's have a look at one more example of these. So here's my equation. 3x plus y equals 13 and 5x minus 2y equals 7. Once again, you can see that the coefficients are not the same. So I'm going to multiply my top equation by 2, therefore making the coefficients the same. And I'm going to rewrite the equation, 6x plus 2y equals 26, 5x minus 2y equals 7. Because these are different, I have a plus and a minus. In order to eliminate the y's, I need to now add the two equations. 6x plus 5x is 11x. 2 plus minus 2 is 0, it's eliminated. And 26 add 7 is going to give me 33, which means x must be 3. And then once again, I put it back into the equation. 3 times 3 plus y equals 13. 9 plus y equals 13. So y must be 4. Okay, last example I'm going to show you. So once again, we have our simultaneous equations, and once again you can see that the coefficients are not the same. So instead of just multiplying 1, this time I'm going to multiply 2 of my equations. I'm going to multiply this equation by 2 and this equation by 5. I'm then going to have 4y plus 10x equals 62 and 35y minus 10x equals 55. Remember, the signs are different, so I'm going to add the two equations together to eliminate the variable I don't want. 4y plus 35y so 39y equals 117, which means that y equals 3. And we put our value for y back in, just like we've been doing before. So when y is 3, 2 lots of 3 plus 5x equals 31. 6 plus 5x equals 31. 5x equals 25. X equals 5. Okay, now it's time for you to have a go. So I've put two equations here for you, and I want you to have a go at solving them. In the next lesson, I'm going to expect to see both of these equations solved with all the working out clearly shown. So press pause on the video now and have a go at solving them. On the next screen, I'll give you the answers to the variables, but make sure you press pause, solve them for yourself, and in the lesson next, I want to see the full working out to solve these two simultaneous equations. Okay, hopefully you got x equals 6 and y equals 5 for the first equation, and for the next one, v equals 1 and u equals 5.